Hello students, welcome back to my channel. Today I have come with few questions from mechanics, particularly the kinematics and work power energy and all, which have been picked from the second shift 29th January 2023 JEE mains. So let us discuss them one by one. Here comes the first question. You can see an object moves at a constant speed along a circular path in a horizontal plane with center at the origin. The object is at x equal to plus 2 and its velocity is this. The velocity is the object's velocity and acceleration has to be found. So let us draw the diagram first to understand the situation. So these are the x and y axis. This is the circle. Okay. Since it is going along a circular path in a horizontal plane with center at the origin, and when the object is at a distance plus 2, this plus 2, that means this radius must be 2 meters. This is 2. And its velocity is always tangential. It is given minus 4 j cap, means it is along the negative y axis. Numeric value is 4 along the negative z axis. So the speed is 4. These two things are clear. And since it moves with constant speed, its speed will remain same. So that means it is going along the circle in the clockwise sense with a speed of 4 meters per second along a radius of 2 meters. Now we have to determine the object's velocity and acceleration at x equal to minus 2. This point represents x is equal to minus 2. X is equal to minus 2. So this will be, when the object comes here, its velocity will be along the positive y axis. So the vectorially when you express, you have to multiply with the unit vector along the positive y direction, that is 4 j cap. And its acceleration is centripetal acceleration directed towards the center. So the velocity is 4 j cap and acceleration, as you know, it is along positive x axis. So unit vector along positive x axis is I cap and its value is v square by r. So v is 4 into r, so 8. So second option is the correct option. Moving on to the next question. Identify the correct statements from the following. Work done by a man in lifting a bucket out of well by means of a rope tied to the bucket is negative. Work done by gravitational force in lifting a bucket out of well by a rope tied to the bucket is negative. Now the situation is a bucket is being drawn. Bucket full of water is being drawn out from well. So this is how the string must be there and the displacement is up. Now if you draw the free body diagram, you can see the weight of the bucket is mg, which is also the force of gravity. And the tension in the rope is up, tension in the string or rope. So now you can see, now if we read the first statement, work done by the man means the man who is pulling the rope, that is work done by the tension in lifting a bucket full of water is negative. So which is certainly wrong, because displacement is up and the force applied by the person is also in the upward direction. So both of them are in the same direction. So angle between them is cos 0. Cos 0 is plus 1. So it cannot be negative. Coming to the next statement, that is B, work done by gravitational force in lifting bucket out of well is negative. Yes, this is correct, because force of gravity is in the downward direction whereas displacement is taking in the upward direction. The angle between them is 180 degree and cos 180 degree is minus 1. So work done will be negative. So this is true. Then work done by the friction on body sliding down an inclined plane is positive. This is also wrong because in case the body slides down, the displacement is along the downward direction down the inclined plane, whereas the friction will be acting up the inclined plane. So angle between them is 180 degree. Cos 180 degree is minus 1, so work done will be negative because work done is equal to force into displacement into cos of angle between them. Cos theta being negative, this is wrong. Then D. Work done by applied force on a body moving on a rough horizontal plane with uniform velocity is 0. And this is also wrong, students, because if the body is moving with uniform velocity, there is no gain in kinetic energy, absolutely. But since it is moving on a rough horizontal surface, work has to be done against friction. Otherwise, what will happen? Friction will stop the block sooner or later. So, in case if the block has to be moved with constant uniform velocity, that is constant velocity, work has to be continuously done against the force of friction by the applied force. So, work done is not zero. Then, moving to the next part, E. Work done by the air resistance on an oscillating pendulum is negative. Absolutely correct, because it is the air resistance which stops the oscillating pendulum after a certain time. Because as the body moves in the forward direction, the air resistance is always retarding the movement, which is also known as the viscous drag. So the direction of force, viscous drag, is opposite to the direction of velocity of the bob of the pendulum. So work done is always negative. So this is true. So B and E are true. B and E only. So I think we should go with the first option. B and E are correct. Then moving to the next question. A car is moving on a circular path of radius 600 meters such that the magnitudes of the tangential acceleration and centripetal acceleration are equal. The time taken by the car to complete first quarter of revolution if it is moving with an initial speed of this much. Students, let us convert this speed into meters per second by multiplying by 18. So you can see it is 15 meters per second. Alright. So now it is given that the speed, tangential acceleration is equal to the centripetal acceleration, and centripetal acceleration is this v square by r. So let us obtain a relation between v and t first. Okay, so let us obtain this. So this will be v power minus 2 dv is equal to dt by r. Integrating both sides, we have initially time was 0 and this velocity, for now I'll take it as u. So initial velocity was u here, and right now the time is t, velocity is v. So integrating both sides, we have minus 1 by v. This will be, when you substitute the limits, you have this, and here if you substitute the limits, you have 1 by v minus 1 by u is equal to minus t by r. Minus t by r. So this way we can express v in terms of t. So v in terms of t will be something like this. This v in terms of t. Okay. Now v can be written as ds by dt. Velocity is the rate of change of displacement. So now here finally you can see that we can find the time given, we have been given the distance covered as the first quarter. Quarter means 1/4 of the revolution. So this is a variable separable differential equation. I am separating the variables to the two sides of the equation and then I am going to integrate. So ds is equal to ur dt upon r minus ut. integrating both sides. So initially time was 0 and displacement was also 0, and right now let us say time is some t and displacement is s. So after integrating, the left hand side you will get like this, whereas the right hand side it will be u r into log natural r minus ut whole divided by minus u, integrated between limits 0 to r. Okay, so this will be r times, we can take the, you can absorb the minus sign and interchange the limits. You have ln r upon r minus, or you can do one thing, you can take this minus sign to this side. So we have minus s is equal to, minus s by r is equal to log natural of r minus ut by r. Now we can substitute the values here. Before we substitute, we can write like this: 1 minus ut by r. Therefore 1 minus ut by r is equal to e to the power minus s by r, and finally we have t is equal to r by u into 1 minus e to the power minus s by r. Here in this case s is equal to, quarter circle means 1/4 of the circumference. So 1/4 of the circumference would mean 2 pi r by 2. So this is pi r by 2. R gets cancelled and we are left with this. R is 600 kilometers, U is 15 meters per second. So 1 minus e to the power minus pi r by 2 into r. So r gets cancelled here. So 15 fours are. So final expression is 40 into 1 minus e to the power minus pi by 2. So the required value is 40. This is the time taken. So this is, here the value of t we have to find, and this t is 40. Then moving on to the next question. The time period of a satellite of Earth is 24 hours. If the separation between Earth and satellite is decreased to 1/4 of the previous value, then its new time period will be. This is simply based on Kepler's law. This is based on Kepler's laws. This is Earth, and this is the orbit of some satellite. Orbit of some satellite. Let us say this distance is r, and this is the satellite. Satellite is revolving like this. So the period of revolution for this square is proportional to r cube. This is Kepler's third law. This is based on Kepler's third law. So if we can find the factor of change for t in terms of factor of change of r, then immediately we can solve the question. Okay. So factor of change for t can be calculated as factor of change of r applied by this formula. So let us see. The separation has been decreased to 1/4. So the factor of change for r is how much? 1/4. So this 4 can be done as 2 square. 2 square. So therefore 2 gets cancelled here. We are left with 1 by 2 cube, and 2 cube is 8. So the factor of change for t is 1 by 8. That means what? If you know the factor of change, then immediately you can write the new time period as the factor of change multiplied by the initial time period. What is the initial time period? Initial time period is 24 hours for this. So 8 3s. So correct option is the fourth option, 3 hours. Moving on to the next question. A particle of mass 100 gram is projected at time t equal to 0 with with a speed of 20 meters per second at an angle 45 degree to the horizontal as shown in the figure. The magnitude of the angular momentum of the particle about the starting point at time t equal to 2 seconds is found to be a root k as a units. The value of k is. Now, students, we have two different methods to solve this question. One of the method, the usual method, will take more time, and the other method is you apply the angular momentum angular impulse concept, principle of angular momentum, angular impulse concept. It will be very easy. So let us go with the second method. So just a brief description of the situation through the diagram. The particle has been projected at t equal to 0 with a speed equal to 20 meters per second at an angle theta equal to 45 degrees. So the horizontal component will be 20 cos 45 degree, which is equal to 10 root 2 meters per second, and vertical component will also be the same. That is not required here, of course. That is not required here. Now let us say at time t equal to 2 seconds, it is somewhere here. So we have to obtain the angular momentum. Now angular momentum, angular impulse principle states that the angular impulse is equal to change in angular momentum. Change in angular momentum. So we can write angular impulse is equal to change in angular momentum. Change in angular momentum. Now angular impulse is tau dt, okay, integrated between, let us say, 0 to 2 seconds here. So this will give you change in angular momentum, so which is equal to final angular momentum minus initial angular momentum. As you can see, about the point of projection, initial angular momentum is 0 because it is projected from that point itself. So I can write this as, I'll remove the vector sign. I'll remove the vector sign and I can write like this. L is the required value. Now tau, the torque will be force, that is weight, multiplied by the lever arm. This is the lever arm. Lever arm is the x coordinate, you can see. So this will be F into x. X is Vx into t, because you know the horizontal velocity remains unchanged. So the horizontal displacement can always be calculated as simply the horizontal component multiplied by time, integrated between the limits 0 to 2 seconds. Let us substitute the values and get the answer. Mass is how much? 1 by 10 kg. 100 grams means divided by 1000. G is given as 10 meters per second square. X component of velocity, horizontal component, is 10 root 2 meters per second. T dt. We have to integrate this between the limits 0 to 2 seconds. So therefore, 10 gets cancelled here. Then we are left with 10 root 2. This will be t square by 2. When you integrate this, you will be getting t square by 2. When you substitute the limits, upper limit minus lower limit, you will get this. 2 gets cancelled. You have 20 root 2. 20 can be written as root over 400. So finally you have under root 800. So that this k is 800. 800 as a unit. This is how you are supposed to solve. The other method, which is the usual method, students usually are tempted to solve by the other method which I am about to show you. But that will be a bit lengthy. Let us solve that. Okay. Now you see, The usual formula is the angular momentum is given by m into vector r cross vector v. Okay, so this is how we have to calculate. So this is vector r, that is the position vector of the particle, and this vector v, then now vector r and vector v we have to substitute. Remember, the body is under the influence of a constant acceleration, which is the acceleration due to gravity. So we can always use equations of motion here. So in order to use equations of motion, we can write S is equal to ut plus half at square, and vector v is equal to u plus vector at. Vector a is g. So this formula gives you vector L is equal to m times vector u t plus half gt square cross vector u plus vector gt. Now t can be taken outside. We are left with vector u plus vector gt by 2 cross vector u plus vector gt. Okay, then vector u cross vector u is 0, and we are left with vector u cross this. So vector u cross vector gt, then vector gt by 2 cross u can be written as minus vector u cross gt by 2, and vector g into t by 2 cross vector gt will be 0. So therefore finally we are left with this vector u cross gt by 2. This is the final. So t can be taken outside. So we have m t square by 2 into vector u cross vector g. Now vector u is actually the initial speed into cos theta I cap plus sin theta j cap, where theta is the angle of projection, and this is minus 10 j cap because acceleration due to gravity is minus 10. Now we can simplify to get the final end result. End result will be this mt square by 2 to u naught I cross j. So I cross j is k cap with a minus sign, so minus k cap, and here you can see cos theta will be there and 10 will be there. You see j cross j will be 0, so no need to consider this. Now let us substitute the values. Mass is 100 gram, that is 1 by 10 kg. Time is 2 seconds. Initial speed is 20 meters per second. This is the unit vector, don't worry about this. Cos 45 degrees 1 by root 2 into 10. So finally this 10 gets cancelled, this 2 gets cancelled, root 2 into root 2. So you are left with 20 root 2. So 20 root 2 into minus k cap. Minus k cap gives you an idea regarding the direction, don't worry. If you are interested only in the magnitude, so just pick this value, that's all. So this 20 root 2 can be written as root over 800. So 800 is the answer. That's all in this video, students. Thank you so much for watching my channel. Please subscribe to my channel and hit the like button. Thank you.